Hey, hello everyone. Welcome back to the Kubernetes Project Series. Now, you guys may be wondering about what this series is all about. So, this series is about hands on projects of Kubernetes. And in each video, we will learn about some fundamental concepts of Kubernetes and then we'll apply those concepts in a project to build something real. So, basically, this series is all about good hands on projects of Kubernetes. So, by end of this series, you will not just have the theoretical knowledge of the Kubernetes, but also the good practical knowledge of Kubernetes. So this is the second project of our series, and in this series project, we are deploying a three-tier web application inside the Kubernetes, end to end. So before explaining me more about that project, let me show you what that project is. So this is the project where we have a three different services like front end, back end, and database. Where front end is communicating exposed to the user with, and front end is communicating with back end, and back end is communicating with database. This is completely functional. See, and this data is stored in your database, which is bound to the persistent volume and persistent volume claim. Don't worry, what is that? I will explain that completely in this series. So this is, see, if you replace that, data is still persisted in the database. And if you guys are new to my channel, make sure to like and subscribe because that really motivate me to make more such content. And I also created this GitHub repository where you guys can take a look. I will provide this link in the description. And in this repository, I have only given the Kubernetes YAML files. But if you want the complete source code or like front end and back end code, then you can go to this URL. You can find the complete back end and front end code also the Docker files. So now before getting into the hands-on, I want to explain you what is this persistent volume and persistent volume claim and why we need that. So let's move ahead towards that. So now let's get into this. So we have a deployment and a replica set, and this replica set will make sure that always the desired numbers of pods are always up and running. So that is what we looked into our previous video. So whenever a user connects to this container and user writes some data to that container, let's say he wrote some data. Similarly happens to this and this also. And I also know that pods are ephemeral in nature. Means pods are shortly lived and they can get crashed or terminated. And whenever they are crashed or terminated, this replica set will make sure that it will spin up a new pod. But whenever it spin up a new pod, it will not have the data that previously that user has written. It don't have the data. So the first problem we'll face is that data loss. That is this. And the second problem we will face is that data sharing. Means first and the second problem we'll face is that data sharing means first the user connects to this pod and writes some data to that. And the next time when user comes and connects to this pod, he will see that he don't have the data he had previously written. So there is a no sort of way of data sharing. So we need an external volume for that. So that is what this volume comes in. Volumes is just simply a external storage, a file system so that all the pods can access the data and share the data so that even if one of the pods get crashed or terminated, replica set will spin up the new pod and that new pod will also have a uh, connection to that storage. All the pods will have connection to that storage like this. That is what volumes means. Now the problem is where to keep this storage, that is volume. Now I told you that volume is simply an external storage, a centralized storage where all the pods have access to it and can read and write the data to this volume. But the problem comes in where to keep this volume. We cannot keep this volume in this pod because pods are ephemeral in nature and they are shortly lived. If this pod is destroyed or terminated, this data is lost. So we cannot keep this volume inside this pod. So we need a sort of way to keep this data and persist this data across the pods. So that is where we keep this data at the node level. So this is our node. This is the same diagram as above. So this is the node and this is the pod. Inside this pod we have a container running and we keep the data volume at the node level. That is what we call as a host path also. Means whatever the we what we do is we mount a folder at the node level to the container, a folder path to this folder, we will mount that path to this container. Means whatever the data written to this container will also be written to this folder. Then what happens is, if these pods are deleted or terminated, a replica set will spin up a new pod, and this new pod will also have access to this folder, that is a volume. And now the problem is solved what we had facing previously. Is it so? The answer is for that is no. Why means, because let's say we have a new pod, and this will work for our local development. If you are using it, working with Kubernetes or doing hands-on, then this is good, and this is what we are doing in today's project also, that is we are using a host path for our development purpose. But when it comes to the production, this will fail. Because why? I will show you that. What if you have a multiple nodes, node 1 and node 2, and one pod is here, and there is one pod is here, and this pod don't have a connection to this volume. So how this pod will have a connection to this node? There is a no sort of way of data sharing between these two nodes. And what if this node itself got crashed? This data is completely lost. So again we fall back to these two main problems, that is data loss and data sharing. So that is where the other solution to it comes in as a external volume, that is this AWS EBS volumes. These are external volumes independent of a cluster, and these volumes are connected to our pods and can persist and share the data across the pods, across the different nodes also. So what is this EBS volumes and more? We will look more into it our next video, where we will use this EBS volumes with complete hands-on. So now let's go into our persistent volume claim and storage classes. What are these and how they are used to create a volume? So we'll not look into this storage class because we'll keep this in our next video. We'll use this, but in today's video we will look into this persistent volume and persistent volume claim. So persistent volume, let's look into the actual definition what we are getting in our this documentation. A persistent volume is a piece of a storage in the cluster that has been provisioned by an administrator or dynamically provisioned using a storage classes. So look at this, dynamically provisioned using storage classes. We will look into it more in our next video. What is dynamically provisioned? So now let's look into this. So to explain it more simpler way, what is persistent volume? Persistent volume just simply a YAML file that is referring to a actual physical storage. So in our case, what today we are using, that is host path. That is this. So we are using host path, and our host path, whatever this is our host node, and in this node our data is stored in slash data slash db location, and the storage we are using is 5 GB. And what is this access modes and persistent volume reclaim policy? We will look into it shortly. So this is simply a volume, means it is just simply referring to an actual physical storage. And now what is persistent volume claim? So persistent volume claim is just a claim to this PV. Means whenever we create a PV, persistent volume, that persistent volume is in available state. Then someone needs to use that, claim that, to use that in our pods. So that is where persistent volume claim comes in. This claim will request to this PV resource request storage of 5 GB, and this has capacity is also 5 GB. So this PVC will claim this PV. So those two are in bound now, and now this PVC will be used in this pod. Now I think I know you are not getting this. You will get it more when we will start doing hands-on on this. So stay stick to me. I'll explain it more deeply. So that is what the simply a persistent volume means and persistent volume claim is. So to explain it more simpler way, so let's say this is our PV. This is our PV, and this PV is referring to the actual physical storage, that is in our case host path, that is this. And in this our location is slash data slash db, slash data slash db. So this is referring to this directory, and this PV is been claimed by this PVC. That is this PVC is claiming this PV, and this PVC is being used in our actual deployment in our pods. So this is our pod. So this PVC we will use in this pod, and the same flow goes with our external volume also. Let's say this is our EBS volume. So whenever our EBS volume is this, so this persistent volume will refer to the this external volume, that is EBC, and the rest of the flow goes same. This PVC will claim this PV, and this PVC we will use in our actual pod. Now, if you want to get to know more about what is persistent volume and persistent volume claim, you can follow this documentation. And I have not explained you what is access modes, right? So we have different types of access mode. That is read write once, read only many, read write many. Read write once means the volume is mounted in the node so that only one node can read and write to that volume. If you have multiple nodes and multiple nodes trying to read and write, it will fail. If you have only just single node, then use this read write once. And let's say you want just to read only many. Read only many means you have multiple nodes, and all the nodes you want to only to read the data, then you use this access mode. And if you want both read and write by many nodes, then use this, that is read write many. Volume is mounted as read write by many nodes, means multiple nodes will have able to read and write to that volume. And next is reclaim policies. What is reclaim policy means what should happen to your data when your pod is deleted or your persistent volume claim is deleted. Retain means PV, your data is kept after the deletion of PVC, and you need to manually delete that. That is what retain means. Delete means once your PVC is deleted, your persistent volume is also deleted. And recycle means this is not recommended to use, and it is not also used also much more. That is what it is. And next is config maps and secret. Config maps is just simply a Kubernetes resource which are used to store the non-sensitive data like node envs or API URLs and all those. And secret means same like config maps but are used to store much more secure data. And also the data is stored in a base 64 encoded. So this is base 64 encoded, actual data is different. And now, as we know the good basic understanding of our the concepts that we are using in today's lecture, that is persistent volumes, config maps, and I have not explained the NodePort also, that I will explain now. And this is the architecture of today's what we are deploying, that is the project our. So we have three different services, that is front end, back end, and database. We will deploy these three different deployments, and these three deployments all will have a replica set. And in replica set, we will give the count as two. So we'll have the two pods running of this front end, back end, and database, not database. And we will have a service for all the three deployments. That is for front end and for back end and DB. And we will expose this front end service to our user via the NodePort service, and also the backend also will expose this backend service to the user. And this is not the good practice to expose your backend directly to the user, but again we are at the learning stage. We want to learn, so we are doing that, but in production we will not do this. Instead we will use ingress for that. that is that is we will use an ingress as a middle, and this service we will communicating with this ingress, and the user will be communicating with this ingress. And this ingress is the one able to route the traffic to our both the service. We will look into it more in our next video, so don't worry about that now. So now just simply understand that we have two services, that is front end and back end. We will expose that to the user via the NodePort service. And the speciality of NodePort service is that it will expose the ports at this range, that is 30,000 to 32,767, any port of from this range for this and this, so that user can access that at this location. And simply that's how our deployment is communicating with this service, and this is communicating with this service, and our database is also communicating with this. And these two services are exposed to our user. And this service which is of our DB is not NodePort, rather it is cluster IP, so that we need our database for only internal communication. And this is also the good practice to keep our database as a cluster IP. But most of the cases it is used as headless service. What is headless service? Don't worry, we will look into it. in our future videos. And this is our persistent volume claim and PV. So this is the PV which we will be which is referring to our host path slash host, and this claim persistent volume claim is claiming this PV, and this PV is being used by this deployment, that is database. That is the simple architecture of what we are building today. Now come to our AWS console, move towards EC2 instance, and in this EC2 instance, we'll spin up an EC2 instance. Again, I am using the same instance that I had used in my previous video. Again, if you guys have terminated or deleted that instance, don't worry, spin up a new instance and just simply log in into that instance and install the tools like Docker, Minikube, kubectl. And if you guys don't know how to install those, I've explained that in my previous video, so do check that out. So we'll just simply log in into this. So we are inside our instance now. So now let me first explain all the YAML files of our Kubernetes. So let's start from the front-end deployment. This is the front-end deployment. I've explained this what is deployment in all in my previous video, but let me again explain that. So kind and API version, these two fields will remain same for all the resources in Kubernetes. So the kind is deployment because the resource we are using is deployment. API version is this, and I also told how to get this API version in my our previous video. And next is the metadata. In metadata we give the name of this YAML file, that is front end deployment, and then namespace, which namespace we are creating this resource, that is project 2. And then spec, and then spec we give the replicas as 2. Replicas as 2 means, so in this deployment we will have two pods always running. Even if one pods get deleted or terminated, this replica set will always look for that whether the desired number of pods are running or not. If not, it will spin up a new pod for that. And then selector, in selector we give the match labels at front end. This label should always match to the this label, that is pods label. And then in strategy we give the deployment rolling updates strategy. What is this strategy? Again, I have told in that my previous video. This is just let's say you are in a you are running in a version of your specific application, let's say v1 version, and you want to move to other version, that is v2. How that update should happen, that is what this rolling update signifies. Rolling update max surge means one. Before term, let's say you have two pods running off version v1, and you want to update it to the version v2. Before terminating your older pods, before that your replica set will spin up a new pod of the newer version and then terminate the older versions. And max unavailable means zero. And then in template we just give the metadata, means the label for our pod, that is app front end. And in spec section we give the container details, name of the container, image name, and the ports, container port at which our container at which port our front end container is running, that is port 80. So this is simply our front end deployment. So similarly our backend deployment, everything remains same, just we're changing the names here. As backend deployment name, namespace remains same. Again, labels we are changing to backend, and here uh, container image name we are changing it to, and a port, that is what we are giving here, port 3000, because our backend is running at port 3000. And something we are passing is env from. This is means our backend needs env variables, and those env variables we have created via the Kubernetes secrets, that is it here. So in this Kubernetes, again this two remains same. And in metadata we give the name for this YAML file, that is Kubernetes secret, and namespace, that is project. And this type is just a simply a generic type that is we use in this to store our key value pair. And next is this string data, and in string data we give our URI, that is Mongo URI, and this URI. And understand this, in this when we are developing it in local, we here give over the local host, but in Kubernetes we give the service name of our Mongo, that is Mongo means, I'll explain our Mongo service later. Here we have Mongo, the name of our Mongo service is given as a Mongo, so this service name we will use that in our this URL here. And the pass OP as our database name, and that is our secret. And this secret we will use in our this backend container, env from secret ref means secret reference, from where name of that secret, backend secret, that is what we are given here, backend secret. So we are importing that here. And next is our MongoDB deployment. So MongoDB deployment also remains same, just which changing the names. Replica set as one, everything remains same. But in here containers we give the volume. And but before explaining this, I want to explain you how to create the PV and PVC, and that is what our main focus is on also. So let's go to our PV and PVC. So this is our PV persistent volume. So again, these two remain same, kind and API version. And in metadata, we give the name as Mongo PV for this PV. And here we don't give any namespace because PV are cluster scoped, not namespace scoped. And next is spec. In spec, we give the capacity as storage as 1 GB. Means in our case, we are today using is as node port. Sorry, not node port. We are using the host path. Means we are storing the data at our node itself. And at node, we are telling that use 1 GB of the data. And access mode, what is this access mode? I have told it. Read write once means we have only one single node, and that one single node is only will have the read write access. And the host path, at that node at this location data will be stored, that is data slash db. And the storage class name is just the value that we will use in our pvc to reference it. So this is our pv, and next is our pvc. So this is pvc, kind as persistent volume claim, api version v1 metadata. And pvc are namespace scoped. So PVC we give the name as namespace as project 2. And in spec access mode read write once. Understand this? This access mode and this access mode should be same. If they are different, then your PV and PVC will fail. And in resource request, we are requesting 1 GB of the data from our PV. When we are creating this PV, our PV will come in our available state. And once we create this PVC, that PV and PVC are in bound with each other. I will show you that when doing hands-on. And next, once we create this PVC, we will use the reference of this PVC in our MongoDB deployment. That is here what we are using. So for this container, volume as Mongo, name of the volume that we are giving as Mongo data, and persistent volume claim name as Mongo PVC. So this volume is referencing to that PVC, and PVC is referencing to that PV, and PV is referencing to our actual physical storage in our node, that is host path. So that is what this volume is. And in container, at this location data will be stored, and also this data is mounted to the our host node data path, that is this data slash db. That is what we are told it, a mongo mount, a volume mount name is this name, and mount path at data slash db. So this is it. And next is let's show me let me show you the service. And I've not showed you this project namespace, how to create namespace. Kind API version metadata name as project 2. So this will create simply a namespace called project 2. And next is we have front end service. So this is our front end service. And as I told in our previous video, we had used cluster IP service, which is default one. But in today's video, we are using the service as type NodePort. NodePort means it will expose the port from this range 30,000 to 32,767. Any one of this port will be exposed from your node. So the kind as API version, metadata, you give the name, namespace, and in spec selector app frontend. So this service is bound to the this selector, that is app frontend. So it will look for the label. So our frontend has also this label. You can check that it. So this is our front-end deployment, and in front-end deployment, we have given the label as app front-end. So that is what we have also given in our service also, and type as node port, ports, and this is the array, a port 80. Port 80 means our the port of our service. That is this service port 80, and target port means the port at which our container is running. Our front-end container is running at port 80, and we have also exposed that port right here. Our container front end container is running at port 80, so that is what we give here. Target port means, and node port means the user should able to access at port 30,080. At this port, whenever user hits that, his request will be routed to the container's port 80. That is what this tells. And next is we have front backend service. Backend service is also the same type as node port, and the selector as backend, and port as 80 means this service port service is at port 30,000. Target port means the backend container is running at port 3000. This is our backend container running at port 3000. And node port is this, that is 30,081. That means anyone user if hits this port here, that request will be routed to this port of the container. And now next is Mongo service. So Mongo service is also the same, but we are not using node port, but we are the cluster IP, which is the default service also. So just simply we are creating a service cluster selector as app Mongo, and this is a reference of our Mongo deployment. That is this app Mongo, and the port is simply the port of the service, and target port is our Mongo's port, that is 27,017. So these are the all YAML files of Kubernetes. And now we look into the hands-on directly to our server. So now we are at our server, and what I've done is I've copied all the files to this location on our server, that is project 2. Inside that KTS folder I have all these folders. I have copied those, and now we'll start applying all those folder one by one. So let's start from first creating the namespace. So this will create a namespace for that. You can check that by this kubectl get ns. See here, a project 2 namespace has been created now. So next we will apply our front-end deployment. But before applying our front-end deployment, we need to build our image for our front-end. Why means I need to show you that. So now before applying our front-end deployment, what we need to do is to build our front-end image once again. Why means come to this repository. Again, I will provide the link of this repository. You guys can take a look. So here in this repository, I've given the link of this. Go to this URL at KTS folder. That is this password manager. Come to this KTS repo, KTS branch, and in the branch front end you can find that Docker file. So in this Docker file, we are passing the URL, React API URL, and we are passing this URL at build time, not at runtime. So that is why we need to change that URL. And the command for that is this docker build -t, and this is the name of the image that we are giving. Hyphen build arg means argument that we are passing here, and that argument will be the URL of the location where our backend is running. Means we'll simply take this and we will change that URL to the current URL of our server. That is this. Our server is running at this IP. So we'll take this IP, we'll paste that and colon 3000, 30,081. 30,081 is this. That is come to your backend cat backend SVC. So in this backend SVC, we have given as port 30,081. So this is the location where our backend is exposed. So that is what we are giving that in our Docker file also. That is what we are giving here, and we will simply create that image. I think my Docker is off. So this will create a new Docker image with this URL, and we will push that URL to our Docker registry, and then we will use that image location at our. So what is we are getting here? Docker build. I think we are getting this error because I was logged out of my Docker hub. So I have logged in again once again, and we are running this command once again, and now this will run. and this will simply create a Docker image for us, and that image we will use in our deployment. So yes, the image is created. Now let's push this image. So this image is now pushed to my registry, and now simply get it to here. What you need to do is cat. You just need to change the IP, image to the same name that you are using. So my image name is same now, that is this. And then once this image is now pushed, now I will apply that kubectl. So deployment is created now. You can check that kubectl get you in the namespace project 2. So PO is the short form of our pods. So see, our two pods are up and running now. So now let's apply our backend pods also. So but before applying our backend deployment, we need to apply our backend secret, that is this, because our backend file need that. So let's apply first that. So it is created now. So now let's apply backend deployment. Now let's apply. Now we need to apply MongoDB deployment, but MongoDB deployment, before applying that, we need to create a PV and PVC because our MongoDB needs a storage for it. So what we will do is first apply our PV kubectl. So a PV is created. So let me show you that kubectl get PV. So see, we applied a PV. A PV is created name PV with capacity of 1 with access mode read write once, and reclaim policy by default it is retain available. See, this is important. Status as available, and claim we don't have anything. Once we will apply that claim, that is our PVC, we will get claim as our PVC name. So let me apply that also. So we applied that our PVC. Now let's look into our PV once again. See, same. Now before it was in available state, now it is in bound state. With whom it is in bound? That is project to Mongo PVC. This is what I was telling you. This PV is referencing to our actual physical storage, and this PVC our referencing to this PVC PV, and this PVC we will use that PVC in our deployment, Mongo deployment. That is what I explained in our YAML file also. And now our PV and PVC we have applied. Now let's apply our uh, Mongo deployment. So our Mongo deployment is also applied. So now let's look into what all we have created, applied. Well, get all in the namespace. See, two parts of backend, two parts of front end. One is for MongoDB, and these are the services, not services. These are the deployments. These are ports, and these are deployments, and these are the replica set that we have. Now let's apply the services. So here we applied the front end service. Now let's apply the backend service. Backend service is also applied. Now let's apply the Mongo service. Mongo service is also applied now. Now let's look into all the things that we have applied now. So yes, we have now two backend pod, two front end pod, one Mongo pod, and three services of each service, that is for front end, backend, and Mongo. And now our two services, that is for front end and backend, are of type NodePort. So since they are NodePort, we need to port forward them so that user can access that. So how to port forward that? kubectl port forward SVC service. This is the service. Short name is SVC, and then use this name in the namespace project 2, and at which port this is exposed, that is port 30,080. So that is what we need to give here, 30,080 colon user will access this and the request will be forwarded to port 80 of which is our containers port, and give hyphen hyphen 000. This means anyone can access this. This is very much required for our port forwarding, and then ampersand for detach mode. Just hit enter. So now the forwarding from 0.0.0 colon 30,080 to port 80. So it is port forwarding the request. Now let's port forward the backend service also. So backend service will remain same. Just the port is this, and our backend is running at port 3000, and name backend service. This name is this backend service. This we are using it here, and then simply hit enter. So now the backend port is also port forwarding. Now what you do is come to your console, take this IP, and then colon 30,080, and this is the location at your port is forwarded. Hit enter. See, you will be able to access your application. And now you can just simply add any data here. See, data is added, and you can delete also. See, and I told that it is not a good practice to expose your backend service, but we have exposed that. What happens if you exposed that means, if you go to your IP, this same IP, open in another tab, at port 81 you have exposed that. If you any users then hit that, he can able to access. Let's say we have a API service C, he's able to access your backend route at this location. So this is not the good practice to expose your backend service directly on any certain port. That is what we have done it. We will look into how to avoid this, and to avoid this we will use the ingress for that. That is what we will look into our next video. So, and yeah, our port is now forwarded and request has been routed perfectly. Everything is working fine. And now what happens is, and I have told you that our pods are ephemeral in nature, means even if they are deleted, the data is lost. So for that we have used the host path, so that even if the pod is deleted, the data remains persisted. So now let's look into that. So what happens is, so this is our Mongo pod and data is being written to this Mongo, and whenever if this pod is deleted, technically the data should be deleted also. But what we have done is we have used a host path, and we are persisting our data at the host path. And let's first look into that data. So what you need to do is, so we are using minikube, right? Minikube ssh. So now we are inside our host. So now at which location we are storing our data? Slash data slash db. Go to that directory, slash data slash db. Do ls. See, this is all the data that you have written inside this. Whatever you have written here, the data is coming over there. You have and this data is being persisted, means even if this pod is terminated or deleted, this data will remain. Now let's look into that also. Let's first exec into this pod and see whether the data is also in this pod also. So for that what you need to do is docker ps grep Mongo. Why Mongo? Because the name of our deployment is Mongo. Just simply hit enter and you will see that this container is running, which is our Mongo container. Just take its ID and docker exec hyphen it, that ID space bash. Hit enter. Now you see that root at the rate MongoDB means you are inside your Mongo pod. Sorry, Mongo container. And now inside that, do ls. You can see this data directory. Go into that cd data. Do ls. You can see that db cd db. See, all this data is written. What technically happens is, here first the data is written here, and this data, that this location slash data slash db is also mounted to the host path, that is slash data slash db. So whatever the data written here will also be written over here. So what happened then, if you delete this container, that is MongoDB container, you still be able to find that data. Now let's do that practically and see. What we will do is we will delete this container and rerun this container, but then still also you will able to access that data. Just come out from this, exit, and then So now let's terminate this container or pod. Kubectl hyphen f mongo deployment, right? So kubectl delete hyphen f mongo deployment. So mongo deployment is deleted. Now again rerun that. Kubectl apply. So MongoDB deployment is again created. Now come back to your server and just refresh it once again. But see here, you will still be able to access your data. Even if you deleted that container and rerun it, you can still able to access that data here. Means your data is still persisted at that location that I have showed when exec inside that and showed. So this is the use of this host path. But again, this is not useful. But why? What if your host node itself got crashed or deleted? Here we are using Minikube, but in actual when we will be using EKS, we will be running a multi-node cluster, means a server master node. With that we will be running a two different worker node, and the all the workload will be running on that worker node. What if that worker node only is got deleted, and all the data stored in that node will also be deleted? So for to avoid that, what we will be using is external volume, that is AWS EBS volumes, and more, and we will be looking into that in more in our next video. We will use our EKS, that is AWS EKS, and we will also use EBS volumes. We will also look into ingress and much more in our next video. So yeah, that's it for this video, and we have successfully deployed our project. That is this, and you can also add this project in your resume also. And yeah, that's it. And don't forget to take a look into this repository. I've also given a brief intro on this, what is PVC and all. And and once you are done completing your work, don't forget to get out from this pod. Before getting out, simply first terminate all the workload. Kubectl delete ns project 2. So by this command, everything inside this project 2 will be deleted. Just so once all the workload is deleted, just simply exit from this server, and you can terminate or delete this instance if you want. So for now, what I will do is just simply, you can just simply stop or terminate your instance. And yes, that's it for this video. And if you guys are new to my channel, please make sure to follow me and subscribe my channel and like this video, because that really motivates me to make more such content. And yes, we will see you in our next project, that is using EBS volumes and ingress. Yeah, thank you.